There are different types of motors: induction motors, permanent magnetic synchronous motors, switched reluctance motors, synchronous reluctance motors, etc. The reluctance motors are used for various applications. The main idea of working behind the reluctance motors is the reluctance concept. The reluctance concept has a very old history and it can be traced back to before 1900. The word meaning of the magnetic reluctance or magnetic resistance is the property of a magnetic circuit of opposing the passage of magnetic flux lines, and the reluctance is equal to the ratio of the magnetomotive force to the magnetic flux. The reluctance concept can be easily understood by using the method described below. For this, for the magnetic field lines, these are the magnetic field lines. Here we are using two different objects for understanding the concept. One is the isotropic material and another one is the anisotropic material. The isotropic materials are the materials whose properties remain same when tested in different directions. But in anisotropic material, the properties are varying when we tested in different directions. At first, we place an isotropic material here. This object is called object A. The magnetic property of this material is same in all directions, and then we are placing an anisotropic material here. For this material, the magnetic conductivity is different in different directions. This object, based on the direction of magnetic conductivity, there are two axes. One is D axis, this D axis. The other axis is 90 degree away from the D axis, that is Q axis. The object having the property of anisotropic is called B material. B object. The object B consisting of anisotropic material has a different conductivity along the D axis and the Q axis, while the isotropic material A has the same conductivity in all directions. The magnetic field that is applied to the anisotropic object B creates a torque if there is an angle between the D axis and the lanes of the magnetic field. The D axis and the lines of, and there is an angle called delta. The D axis of the object B does not coincide with the lines of the magnetic field. The object will introduce distortions into the magnetic field. In this case, the direction of the distorted magnetic lines will coincide with the Q axis of the object. In reluctance motors, when supply is given to the stator winding, the revolving magnetic field will exert reluctance torque on the unsymmetrical rotor and tending to align the salient pole axis of the rotor with the axis of the revolving magnetic field. Because in this position, the reluctance of the magnetic path would be minimum. If the reluctance torque is sufficient to start the motor and its load, the rotor will pull the stud with the revolving field and continue to run at the speed of the revolving field. This is the basic working principle of the reluctance motor.